Ever thought about the universe shrinking to the size of an atom? Welcome to the realm of quantum physics. This world beneath the world, where atoms and particles dance to a tune that defies our everyday logic, is not just strange and intriguing, it's quantum. Quantum physics, or quantum mechanics, is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. It's the world of the super small, the underlying layer of reality that exists at the atomic level. Now let's touch on two of its most fascinating principles: superposition and entanglement. If you thought the world of the everyday was strange, buckle up. Quantum physics is about to take us for a ride. First off, superposition. Picture a coin spinning in midair. It's not simply heads or tails, but both at the same time. That's superposition. It's the idea that a particle can be in multiple states at once. And it's not until we measure it that it chooses a state to be in. And then there's entanglement. Imagine two particles connected in such a profound way that no matter how far apart they are, the state of one instantly affects the state of the other. It's a correlation that extends beyond the limits of space and time, a phenomenon Albert Einstein famously described as spooky action at a distance. These are just a few of the mind-bending principles at the heart of quantum physics, principles that not only challenge our understanding of the universe, but also hold the key to technological advances that could transform our future. Quantum physics is like a magic show where particles can vanish, teleport, or be in two places at once. But it's not magic, it's the fundamental nature of our universe, the underlying reality that we're just beginning to understand. And it's fascinating. Quantum physics, a realm where the impossible becomes possible. Welcome, and let's dive deeper together. Imagine a cat that's both alive and dead at the same time. Sounds bizarre, right? Welcome to the concept of superposition. Now let's delve a bit deeper into this peculiar world. Quantum superposition is the principle that tiny particles can exist in multiple states at once until observed. It's an integral part of quantum mechanics, the theory that describes the tiniest particles in our universe. Let's illustrate this with a thought experiment conceived by physicist Erwin Schrödinger. Schrödinger imagined a cat in a sealed box with a radioactive sample, a Geiger counter, and a vial of poison. If the Geiger counter detects radiation, the vial shatters, releasing the poison and killing the cat. The catch here is that the radioactive decay is a quantum event. It can either happen or not happen, and until we check, both possibilities exist simultaneously. So, according to quantum superposition, the cat is both alive and dead at the same time, until someone opens the box to check. It's only when we decide to peek inside that nature makes a decision, and the cat becomes either alive or dead. This seems strange to us because we're used to seeing things in a definite state. But in the quantum realm, things don't work that way. It's also worth noting that this isn't about the cat being half alive and half dead. No, it's about the cat being fully alive and fully dead at the same time. It's about embracing the and rather than choosing the or. It's about understanding the possibility of multiple realities coexisting until one becomes our observed reality. This thought experiment, while it might seem far-fetched, gives us a glimpse into the weird and wonderful world of quantum mechanics. It challenges our everyday experiences and urges us to rethink our understanding of reality. And so, in the quantum world, a cat can indeed be both dead and alive. Scene script: two particles separated by vast distances, yet affecting each other. Sounds like science fiction? It's quantum entanglement. Quantum entanglement is one of the most intriguing phenomena in quantum physics. It's a phenomenon that Albert Einstein famously referred to as spooky action at a distance. But what exactly is it? Well, when two particles become entangled, they form an immediate connection. Regardless of how far apart they are, a change in the state of one particle will instantaneously affect the state of the other. Picture this. Imagine you have a pair of dice. You roll them, and no matter what, they always land on the same number. It's as if they're connected, right? This is a simple analogy for quantum entanglement. Now, you might be wondering, how do we know this isn't just a coincidence? Great question. Scientists have conducted numerous experiments to test this phenomenon, and the results have been astonishingly consistent. One such experiment is the Bell test, named after physicist John Bell. Bell devised an experiment that would either prove Einstein's local realism or favor quantum mechanics. The results of these tests have overwhelmingly supported the predictions of quantum mechanics, providing strong evidence for the existence of quantum entanglement. But let's not get too carried away. While quantum entanglement may sound like a magical phenomenon, it's still grounded in the laws of physics. It doesn't allow for faster-than-light communication, and it doesn't defy causality. Quantum entanglement remains one of the most fascinating and mysterious aspects of the quantum world. It challenges our understanding of the universe and continues to be a hot topic of scientific research. The implications of quantum entanglement stretch beyond the realm of physics, touching the fields of information technology, cryptography, and possibly even biological systems. Quantum entanglement, where distance is just an illusion, computing at unimaginable speeds, solving complex problems in seconds. Welcome to quantum computing. This isn't a far-off reality or a sci-fi plot, it's the here and now. It's a fascinating world where the quirky principles of quantum physics meet the precision of computing. So, what exactly is quantum computing? In a nutshell, it's a type of computation that utilizes quantum bits or qubits, unlike traditional computers that use binary bits. These qubits can exist in multiple states at once, thanks to a property called superposition. This ability to be in several states simultaneously allows quantum computers to process a vast number of computations all at once. Imagine having a supercomputer in the palm of your hand. That's the power of quantum computing, but it doesn't stop there. Quantum computing also harnesses another peculiar property of quantum physics: entanglement. In the quantum world, entangled particles become linked and can instantaneously affect each other, no matter how far apart they are. This spooky action at a distance, as Einstein once called it, allows quantum computers to process information in a way that's significantly faster than any existing computer. Now, you might be wondering, what's the real-world application of such a powerful technology? Well, the potential is virtually limitless. From modeling complex chemical reactions to optimizing logistical problems, from enhancing artificial intelligence to cracking encryption codes, quantum computing could revolutionize every industry. However, it's important to note that quantum computing is still in its infancy. There's much we don't yet understand, and many challenges to overcome, but the progress we've made so far is promising. Scientists and tech giants around the world are racing to unlock the full potential of this groundbreaking technology. Quantum computing, the future of technology, is here. Quantum physics is not just about particles and laws, it's about changing our understanding of reality. Imagine a world where the norm is to exist in multiple places at once, where actions can influence others instantaneously across vast distances, where time can both move forward and backward. Sounds like a fantasy, right? Well, welcome to the fantastical world of quantum physics. Quantum physics, with its mind-bending concepts, has revolutionized our perception of reality. It's not just about calculating the movements of subatomic particles or predicting the behavior of light. It's about understanding the fundamental nature of the universe itself. Quantum physics has shattered the long-held beliefs of classical physics and introduced us to a reality far stranger and more intriguing than we could ever have imagined. Take superposition, for instance. It's the idea that a particle can exist in all its theoretically possible states simultaneously. That's like saying you're both sitting at home and running a marathon at the same time until someone checks on you. It defies our everyday experience, and yet it's a central tenet of the quantum world. Or consider entanglement, often described as spooky action at a distance. Two particles can become entangled, meaning the state of one instantly influences the state of the other, no matter how far apart they are. It's as if telepathy exists, but for particles. These quantum phenomena are not just academic curiosities. They have profound implications for our understanding of reality, forcing us to question our assumptions about the nature of existence. They have sparked debates in fields as diverse as philosophy, metaphysics, and even theology. Quantum physics has blurred the boundary between science and philosophy, between the tangible and the abstract. It's a field where the observer influences the observed, where probability reigns, and certainty is hard to come by. In the quantum world, reality is not just what you can touch or see. It's a wild dance of possibilities, a chorus of probabilities. It's a reality that's fluid, interconnected, and beautifully unpredictable. Quantum physics, a key to understanding the mysteries of the universe.